All right, today we're going to be starting chapter 4, which is all about real numbers. So, our first lesson today is going to be about divisibility, different types of numbers, and greatest common factor. So, the first thing we're going to discuss is the divisibility rules chart. All right, so this chart tells you if a number is divisible by 2, 3, 4, 5, 6, 9, or 10. All right, so within each of these, there are some different rules. I'm just going to have you look over them rather than going through each and every one. They're pretty self-explanatory, very easy to understand, but they're very useful for when you're learning about how numbers work together and making things a little bit easier on yourself. All right. All right, so now we're just going to dive into what we're going to talk about today. So the first thing we're going to discuss is what is a prime number. A prime number is a whole number that has exactly two factors, one and the number itself. So an example of this would be 2. Only 1 and 2 can be multiplied together to get an answer of 2. Another example of a prime number could be 13, 17, 51. There's a bunch of them out there. All right, but 2, 3, 5, 7, those are the most common small ones. All right. Um, so that brings us to all the other numbers that are not prime numbers are called composite numbers. Composite numbers. A composite number is a number that can be broken down into two or more factors. All right, so an example would be um, 16. We have 1, 2, 4, 8, 16 because 1 times 16, 2 times 8, and 4 times 4. Another example could be 6. 1 and 6 can be multiplied together. 2 and 3 can be multiplied together. All right, so um, just do a quick review of this. So 2 is considered a prime number. 9 is a composite number. 3 is a prime number. 13 is a prime number. 12 is a composite number, so on and so forth. All right, so we can use these prime numbers to actually break a number down into what's known as prime factorization. Prime factorization. Prime factorization breaks down a number's factors into prime numbers. So instead of talking about the different factors as, um, 1, uh, 16, 4, 2, and 8, half of those are not prime numbers. We're breaking a number down into just those prime numbers. So for example, we have 24. We can use what's called a factor tree to create this. I, in my opinion, think this is the easiest way to do it. Um, it's up to you if you have another method. There's a dividing method where you can do kind of a long string of divisions. You could do, okay, that's 6, that would be 4, and you can go down that way. I don't particularly like that. It just seems a little bit long, but if you want to use that, it's fine. So factor trees, we can break 24 into 6 and 4. Does not have to be 6 and 4. It could be 2 and 12. And break 6 down even further to its prime numbers, 3 and 2, 2 and 2. Once you have a prime number, you stop factoring. That um, that means that you do not have to break 2 down into 2 and 1. Okay? All right, so no matter how you break up the number, the factors will always end up the same. So here's a great example. We have 56 and 56. So the first one here breaks it down into 28 and 2. 2 is a prime number, so we stop there. 28 can be broken down into 14 and 2. 2 is a prime number, we can stop there. 14 we can break down to 7 and 2. These are both prime numbers, so we can stop there. So then our prime factors would be 2 times 2 times 2 times 7. Okay. Um, the other way you can do it is if you want to break it down into 8 and 7, you can do it that way. Break it down to 4 and 2, break 4 down to 2 and 2. As you can see, you get the same answer. All right, so let's do one real quick. We'll do 50. So we'll break 50 down into, let's say, 5 and 10, since that seems to be the most obvious. 5 is a prime number, so I'm just going to stop there. I often like to circle my prime numbers just to keep it a little bit more organized. I then can break down 10 into 5 and 2, and these are also prime numbers. So then I know that my answer would be 2 times 5 times 5, or we can also write it as 2 times 5 squared. It's often better to do it in an exponential form, meaning putting doubles into exponents or triples into exponents, just because it eliminates the amount of writing you actually have to do. Okay? All right. So coming off of that, there's something called a greatest common factor. A greatest common factor. And a greatest common factor of two numbers is the largest factor shared by both. You can determine the GCF, as it's often called, by calculating all the factors of both numbers and finding the largest one. So for example, we have the factors of 44, which are 1, 2, 4, 11, 22, and 24, or 44. Factors of 66, 1, 2, 3, 11, 22, 33, and 66. Our largest number that they both have in common is 22. Now, if you've noticed, all of my factors are listed from smallest to largest. That often makes your job a lot easier when you're trying to find a number that they both have in common, because then you can go straight down the line and see which ones are the largest and see when they match up. Okay, so for example, we have factors of 18. We could do 1, 2, 3, 6, 9, and 18. Factors of 24, we have 1, 2, 3, 4, 6, 8, 12, and 24. All right, you look along here. Well, no, no, no. Oh, found some that are in common. So our greatest common factor would be 6. All right. The other method, and the reason I started this lesson off with talking about prime factorization, is you can actually use those factor trees to find the greatest common factor. This is just another option for you if you don't like listing out all of the factors. So what you can do here is if you have, for example, 36 and 54, you can do factor trees for both. And then you can figure out their prime factorization. So for 36, we have 2 times 2 times 3 times 3. 54 is 2 times 3 times 3 times 3. You double up the ones that they have in common, multiply them together, and that will get you your greatest common factor. All right, so to demonstrate that, we could do 8 can be broken down into 2 and 4. 4 can be broken down to 2 and 2. So then I could have 2 times 2 times 2. 24 can be broken down to, let's do 2 and 12. 12 can be broken down to 3 and 4. 4 can be broken down to 2 and 2. So then we are given 2 times 2 times 2 times 3. So then I can double them up. I can say, okay, I have my a 2, another set of 2's, another set of 2's, and nothing else. So then I can do 2 times 2 times 2, which 2 times 2 is 4, times 2 is 8, and your greatest common factor is going to be 8. All right, so it's just another option for you. Whatever method you find is the best for you, you can use that one. I am not going to dictate which method you use. That is not the point of the greatest common factor. I want you to be comfortable with how you're solving the problems. All right, you just need to show me your work. All right, so that's all I have for you today. Be ready to talk about this tomorrow. If you have any questions about prime factorization, the greatest common factor, or the difference between prime and composite numbers, please just let me know.